Hello, everyone. As I've already introduced myself, I'm going to do it again, pretend like you haven't met me yet. My name's Francis Wertz. I'm a resident in Lancaster County, work in software for a company called Holman out of Jersey. .NET stuff, nothing we're going to see here today. This is a talk, Intro to SDR, Software-Defined Radio. That typically is packaged in a small USB-type dongle you cannot see very well because it's hidden, tucked away down here. They come in a couple different shapes and sizes. The majority of them are receive only. They don't actually transmit. Some of them do. I'm not there yet. How are my levels? My level's good. Hey, good. Level's good. Cool. Yeah, software-defined radio. They're small and cheap. This one with the whole kit, because it came with like a tripod, a couple of antennas, all that, $40. So pretty easy to enter into this world. They span a pretty decent bandwidth. I think this one supports, I think it's like 10 kilohertz up to 100 and, no, it's like 100 megahertz or something. No, I forget what it is. It's like 1,000, I don't know. It's a pretty good range. You know, you can get into all the FM stuff and all that pretty easily. A lot of the cool bands. There's a lot of options on the market. This one is the first one that came up on Amazon when I was looking around, so that's why I own that. Quick segue. Why am I here? My water bill. What does that have to do with radio? A couple months ago, I thought that there would not be linked in any fashion. So yeah, nice to meet you, stranger. So it's probably, what, mid-2020, you know, we're in the throes of the pandemic, working from home, working from the couch still, because I don't have an office yet, because I didn't finish it. And I noticed just someone was just walking down the street, just ping-ponging between houses, just zigzagging like, you know, they were delivering the mail. But instead, they were accosting everybody's homes. They were walking up into the yard, just in plain street clothes, hoodie, nothing, you know, holding this little thing. They'd walk up to the side of the house and go, boop, and then right on to the next house. And so the first time that happened, where our water meter sits, is kind of tucked in the corner of our house. And so we have some windows there. It's like our Four Seasons room. And I vaguely remember Emma just going, and just looking out. And there's this dude just standing right by our house, boop, and then looking in and just walking off. I was like, what was this all about? And so I was like, well, what was he doing? And clearly I saw what he was scanning. And then I was like, okay. And that got me thinking, like, well, what is that thing on the side of my house, first of all? Why is he scanning it? You know, is it water, electric? What's the purpose of this? Is he seeing how much I shower? How much electricity am I using? Is he trying to get my Bitcoin rig? Steal Emma? Yeah, that could have been his thing the whole time, trying to break into our Wi-Fi. So yeah, naturally I had to figure this out, which for me means get into it, figure out that it's way too complex for this brain, and then, you know, just bow out. So, warning, if you are a big fan of like clean meters and stuff like that, look away now. This is the outdoor unit, nicely sealed for weather. So this is the little, I guess, nipple that he would scan, and then just go on to the next nipple. And then this is the interior unit. Took me a while to figure out where this wire ran into this, whatever the ECR is. So I traced that. That's how I found this tucked away in the corner of the house. Obviously I know where my water meter was, but it does kind of look like a Ferrero Rocher. It's all wrapped in this like foily looking, I don't know if that's to ground it or to keep me out of it. I have no idea. But at the time I had about 7 million gallons used. Not since I've owned the house. Anyways, back to SDR. This is going to sum up the talk. Radio is pretty complex, so thanks for coming. But in all seriousness, yeah, and just starting to learn about radio, and this is like, we're talking like this year, like July, August time frame is when I got this, because I got really into it. So I spent about a couple weeks getting really into it, and then life got busy, work got busy, and haven't touched it until this week for this presentation. So I got to relearn it again too, which was pretty cool. A couple of big hurdles as far as these go is you're really faced with kind of two main challenges. One is demodulating of the carrier signal, which, for anyone that doesn't know what a carrier signal is, I'm sure many of you do, it's what you typically picture when you think of radio wave, right? It's your sinusoidal wave in space, and then in that wave, or waves, is a hidden signal carrying data. And that signal can be modulated in a variety of ways. I don't even know an eighth of them. But in that demodulation, you can get basically a digital signal from that. And that's what then you then use to basically build out your frames and your packets for your data. pair that to a protocol of a known device, and then you can extract the actual meaningful bytes from that and put something together that's pretty cool. So in looking in a lot of these units, hacking even just like your water meter is a pretty complex process. I found a couple videos from like DEF CON. These people are nuts. They're like on eBay buying up old units. They're going dumpster diving. They're doing all this crazy stuff to find these old units to then bring them home, clean them up, boot them up, see if what data they can pull off of the non-volatile RAM, and then try to hack the machine by reverse engineering it. It's like, it's crazy, yeah. So that's not me. So at a closer look at that, if I go back here to this water meter, you'll kind of notice a couple things here. I don't have a laser pointer, but you'll notice the little thing says AMR system. So that was kind of a first indication of, okay, well that sounds like that could be a protocol or at least something I can at least do some research on. And it turns out it's part of this thing called advanced metering infrastructure. And essentially what that is your water meter, electric meter, depending on how old it is, will periodically broadcast telemetry about what it's totally, like what it's captured, like usage over a certain period, if the health of the device is okay. And for me, for a long time, I assumed like, okay, meter's outside, it goes up to the pole. There's probably some wiring stuff that's going on. I have no idea. But here it turns out it's all done wirelessly. And a lot of these networks are actually pretty impressive. They actually mesh so that your meter can talk to another meter. So if you live way down the lane, the person at the end of the street in the duplex picks up your signal and broadcasts it to the nearest pole, which actually has a repeater device on it, and that ships it off to the nearest, in my case, it'd be like the nearest pump house or something that has the infrastructure in it, where it can then pick up that signal and then log it. So I'm just like blown away by this. Yeah, question?
I always thought that's how it works. So why is this guy going around scanning into residential?
Yeah, okay. So the question is, why is an individual coming around to scan the meters if they're just automatically reporting out to the infrastructure? And the answer is to audit them. So he comes by on a quarterly basis. So after, that was the first time we noticed because we weren't working from home. So he comes throughout the day, so we don't really know that he's doing it. So yeah, I believe the answer is to audit it. They come quarterly to make sure that what they've been sending, what they've been receiving, matches up to what that device reports. Because that reads right from that head. That's wired in direct to the unit. Chances are, if you have a faulty meter, they're going to know about it before you even know about it. I think these things it depends on the model and the industry. These things will broadcast a couple of times a day. So yeah, no big deal. Water meter periodically sends a crazy complex signal out, gets picked up by other pumps, and I have no control over it from there. It sends it to a centralized pump to get logged, and then next thing you know, people know how much I've been showering. Again, I just thought maybe they had something physical that sat in my house that just like a flap, door open, okay, meter, that's how much they use, pressure stuff, I don't know, it's water, who knows? So the process. I was curious about how this worked. I did a little bit of research, figured out that this was that metering system. So I was like, all right, it's a pretty old unit. I did some research on that model, took some while to figure out what Infosys was. And I think it was probably installed in the house in like 2003. So I figured, okay, well, technology was a lot different in 2003. Surely I can at least play with it a little bit. So I picked up an SDR, did some research on the water metering systems, and I found a lot of really cool projects online. And actually, thanks to Tom from the Slack channel. By the way, if you're on Slack, there is an SDR channel. Please check that out. Pick up one of these and start hacking with me. So yeah, he was quick to jump on it. He's done a lot of stuff in this space, and so I really appreciate his wisdom and guidance on getting started. So some research fun. In looking up my device, again, it's pretty old, but a good place to start is looking at FCC docs. So once a device is being tested for compliance and gets approved, all this documentation will appear on the FCC site. All you need is the FCC ID, and that takes you into a documentation system where you'll see stuff about, like they upload the manual, test photos of the device. Usually it looks nothing like the device you have on the side of your house. Internal photos of what it looks like, and then a really important one that is not available for my meter is theory of operation. So this here tells you basically how the radio signal works, right? That's why the FCC is involved in this in the first place, is because it's sending out a signal. They want to know strictly how it works and operates, the power that's using, the bands that's using, and so forth. So On some meters, it's pretty easy to reverse engineer them because you can get on here and you can look up these documents and see exactly, how they're modulating their signal, what the bit patterns are, all that kind of stuff. So I wasn't able to find anything specifically on my meter. I don't know if it's on a slide later, but I did find one that was pretty close. Now, I haven't really done much with that. Again, total radio novice. I'm not out here just like demodulating signals and picking up stuff all by myself here, but I did find some cool projects to help me along the way. So to start, typically these meters operate in I think it's the 902 megahertz up to 928 megahertz. And they have all kinds of channels in between, so they operate in that band, and depending on what channel they are, they'll kind of play throughout that band, and it hops around different channels. So the first thing was just to kind of try to isolate and just see, can I even see these carrier signals? And so that was kind of one step, was just look and see. And there's tons of stuff that you see on those channels, and it's from all different kinds of things. This isn't the only protocol that's using this whole band. So it's like, okay, yeah, there's definitely some activity there. It could be my water meter. It could not be. I have no idea. And so there's some other options too, some of which I've kind of tried. So because it's so old, I figured, well, maybe somebody's just old enough and they don't care anymore. They'll just give me a clue as to how this thing works. So I did actually email the manufacturer. No response. But that's a pretty common way. It's some social engineering to try to figure out how these things work. So I sent an email to the manufacturer. Maybe I could accost the meter guy when he comes back around. Get a little payback, try to understand what he's doing. Haven't had a chance to bump into him just yet. He probably wouldn't talk to me. Or again, like I mentioned, you could buy systems on eBay. I did a little bit of research on this. You can't buy anything attached to my house on eBay anymore, or if it's very hard to get your hands on. And so the option was to like, all right, well, I'll just play around with some projects that already do this, and maybe I can spy on some of my neighbors and see what kind of stuff they have. So there's tons of meters out there that run fully unencrypted. We're not talking sensitive data. It's just stuff like usage, device IDs, all that type of stuff. But typically it'll have the ID written on the outside. So if I was super curious if my neighbor had this kind of electric meter or whatever, I could sneak over and take a look at it as an ID and see what he's been using. And so then from there, I was like, okay, well, this is more my wheelhouse, use some open source projects, do a talk on it, take credit for it, set up some Docker containers, and pretend like I know what I'm doing. So at least build the infrastructure around it, and then when I eventually write the code, actually I probably never will, I'll at least have an infrastructure there to at least handle some of these messages. Question from the audience?
Yeah, you talk about data not necessarily being sensitive, but it could be depending on what one might be doing either legally or illegally.
True.
The question therefore is, if that data is not protected in some way, can law enforcement use that?
The question is, can law enforcement spy on you if your electric meter is unencrypted? Probably.
So for those trying to make meth at home, don't
Yes.
use too much water.
Yes. Okay. Okay.
I'll bypass the meter anyhow.
Yeah.
Pardon me? Will you repeat that?
No.
Or were you just joking or were you serious?
Yes.
Okay. Wait, joking?
Joking.
Okay.
Live near a body of water if you're going to make meth at home.
Grow houses, they bypass.
Buy a pump.
You can see it all the time.
I don't even think you need that much water. That's actually
I don't know.
they've done that. In the past for finding. They wouldn't have done it in New Mexico deserts in Breaking Bad.
Didn't think the talk was going to go this far. Didn't think it was going to take this kind of turn.
So if I'm in a neighborhood that's done that telephone poles,
Oh, you're Amish.
where's my mesh? Is it in the street?
That's a great question. I mean, typically in neighborhoods that don't have any kind of pole infrastructure, they'll usually have that, the underground kind of thing where all the conduits run up. My assumption would be, I mean, radio can go pretty far, so my assumption would be it would just be the neighboring cul-de-sac, or it could very well be in one of those boxes.
They can
Yep.
go neighbor to neighbor to neighbor till they finally find.
Yeah, I don't know if I don't know much about the mesh. Again, these protocols are all pretty well under wraps, so a lot of this is just what people figure out from buying Landis GR devices and taking them apart and figuring out how they actually work.
Can I use your water meter to share music files with other?
I don't. The question was, can my water meter be used as a P2P protocol? I don't think so. I don't know.
Yes, it could. IPv6. You got there before me.
All right, so now I'm gonna take a knee here and kind of walk you through some projects that I've been using. So there's really a handful of them. So the software that actually the software that actually interfaces with these devices, which these devices they became really popular. I think they were like the first kind of era of digital tuners. The radio chips on them. So take a step back even further into like the demodulation of signals. There's kind of a standardized digital signal called an IQ signal. And so these chipsets are really good at taking any kind of signal and then demodulating it into that digital signal called the IQ signal. I can't remember exactly what it's called or what the IQ stands for. It's leaving me right now, probably because of my low IQ. But so that's kind of the basis. And then there's some software from the RTL SDR blog that you can compile. It's a C project that actually interfaces with this device. So one piece of software, this is kind of the primary one that I'm using. Let me kill all this. It's called RTL TCP, RTL TCP. And so basically what that does is that connects to this device and then makes all of the commands like tuning it, telling it to set the gain, all of those commands can actually be done over a TCP protocol. So instead of having to have physical access to this device, you can hook it up on a machine that's networked, and then you can send commands over to it. Now, there are other projects out there that allow you to basically do multiplexing. So if you have multiple pieces of software that want to get a scan of a piece of band for like a short period of time, you can use this. Is that too small? Oh, sorry. You can also zoom in as well. Cool. Oh. So you can set up different clients on your network to basically call and request airtime to this TCP service, and it'll intelligently balance and handle how to handle all those requests. I guess before I do that, it'd be kind of cool if I could at least show you how this thing hooks up just with some local software. So this is a software called GQRX. This is some open source software on a Mac that you can use to connect to the RTL, and you can connect to it over the TCP. It's a bit finicky. I'll try to connect directly to the device. See if this works. I normally don't use this. This was kind of a cool gimmick when I was first getting into it. So you can see we're picking up possibly some AM, could be FM, some sort of radio station right now. We're at the 106.3. Looks like we got some more tunings going on over here. So pretty cool. And then you can switch you can adjust the bandwidth. This is what's called the waterfall. So the vertical lines here, this is the signal represented, and they have a kind of a tuner that you can move up at the very top to jump around. Settings over on the right-hand side, you can adjust your gain levels, squelch, all that kind of stuff. This allows you to like demodulate basic stuff, FM, AM, those types of things. Nothing crazy fancy as far as what I'm aware, but then again, I'm pretty limited. What's that? Another question?
Yeah, I don't know how current it is, but a while ago I read that many of the chips within cell phones have an FM radio. So what I'm curious of is are they SDR?
The question was, are chips in cell phones, the radios in cell phones, similar to SDR? They could be. Like this is when I switch back to the containers, when I run the RTL TCP, we can see the actual, it's Raphael something, right? I forget what the RTL is short for. Probably different. I mean, those are probably running like higher end Qualcomm chips or something like that. These are just cheap little TV tuner ones. And again, they became really popular because it's easy to access the IQ signal off of these devices.
What I meant to ask is the technology the same? Do you happen to know?
I don't know. Yeah, I would think that radios in a cell phone are probably all circuitry, where this is just circuitry to a point, and then it converts it into a digital signal so that you can then, do with it what you please.
Do you have any experience with that block-shaped pulses?
Sorry, this here?
No, the square one.
Oh, I see. Yeah, that could just be. I really don't know what that could be. I mean, it's really hard to tell. What's that? Yeah, and so you actually see some stuff here when I load this up. There's a whole other protocol in a band called the 433 megahertz band, and a lot of like scientific instruments operate on that band. And I actually brought just 'cause this is the densest populated area I've brought this into yet, so I was like, hopefully I'll get some cool stuff on here, because it's really just been like listening, seeing what I could find. But I did bring this little. I don't know if you guys are familiar with this or not. What this would be? Any guesses? What this bad boy does? Comes with a little battery cover. I just took that off for ease of.
Baby bonder?
Nope.
They're fun too.
Similar. Yep. So it's part of a system. So this is actually at my parents' house. It's meant for indoor use only. They had it outside on their porch, and so it got destroyed. I was like, that'd be something cool to kind of figure out. Looks like that might transmit on that scientific band. I researched the make and model. I was like, cool, I'm going to steal this and fix it up. And so now it's just a simple little transmitter, but this operates on that same band. So this is my backup device if I didn't pick up any signals, but that's why I had the laptop running back here when I first got here. Sorry for being early. So I could pick up some stuff to show while I was just sitting here, because I wiped out my Elastic database before I came here. So back to the software. Because thankfully, it's great, Docker Desktop doesn't support USB pass-through anymore, which is really cool. So I had this all set up and working a couple months ago. It was working great with USB pass-through direct to the containers that run all the software. The software I'm using is mostly written in Go, and obviously the SDR application itself is running in C. Now it doesn't work anymore, but thankfully, because we have the RTL TCP, we can just operate over web requests, which is great. It's great until I lock it out because I'm accessing this. So one device at a time, which is another reason why the RTL TCP is great. You can multiplex requests from different pieces of software. So I have two pieces of software. I want to analyze two different bands. Maybe I want to look at ATC messages and try to pick up stuff happening at Lancaster, Harrisburg Tower. I could have some software that scans on that band, looks for pulses, saves that off, opens the device back up to receive from other applications. Haven't done a whole lot of that yet. There is some song and dance required on the code side, but I've seen it done. It's pretty cool. There's also some general purpose tuners as well that'll flip through different bands and will just output to it. Sorry, no, go ahead.
What's the limit, if any, of the number of frequencies that can scan at any one time? Or is it sort of do like a round robin?
It's basically around. So the question was, what is the device capable of when you're doing the tuning? So basically the way tuning works is you tune to a specific frequency, and then you give it a bandwidth, and it will scan in that range. And you're locked in at that moment in time. And then you can basically, like you said, round robin through all of those different frequencies. So a bit about the setup. So I'm using some software so I have two different main pieces of software that I'm using. One of them is called RTL 433, which is a piece of Go. It's written in Go, and it's a project used to scan a variety of different. This is the one I have most of the data on. It's a project used to scan that scientific band. So stuff like weather stations. I've been seeing a lot of TPMS systems, like Schrader valves. A lot of them have like built-in things now for bicycles, cars, all that type of stuff. Seen some stuff from Hyundai in the same space. When I was here, I haven't looked at them yet, but there's some data on there for a smoke detector. So just a lot of like little infrastructure IoT devices that are in that scientific space will transmit on that particular band. So that software is great for picking up those. There's a lot of community support in that. There's a lot of people in there like hacking their own protocols, and as they find out how things are built, they publish there. So what's kind of cool is there's like a little CSV of files or CSVs of all these different devices, and so you can just tune to your specific device, and this thing will pick up the signal, parse it, and then you can throw it into wherever you want. And that's what this setup is. It's basically using RTL 433. It picks up those messages, and then it pipes it to an MQTT server. I'm using Mosquito. And then from there, all bets are off, right? I can just hook up an instance of FileBeat to that, and then I'm taking those messages off to the topics that I tell it and throwing it into Elastic, where I can play around with it in Kibana and see what's going on in my neighborhood, which really isn't much. Mostly just people driving by and then seeing their low tire pressure alerts. So that's what this Docker stack is. This is just a Docker compose file that has all this software wired up. So you'll kind of see some chatter here. Now this isn't going to output any of the signals. I'll switch over to Elastic here in a second. We can look through some of the stuff that I've already captured. And I can obviously delete it and fire that off. But yeah, so you'll see here, this set the frequency to 433 megahertz, and it basically stays tuned right at that particular spot. It doesn't, walk through any kind of bands. It just kind of stays there and hangs out. So it's pulling up. It's basically just reading the signals from that frequency. If it sees a pattern that it matches, throws it to one of the files in the library that will accurately parse it, and then turn that into a message that we can pick up in MQTT. And what that looks like is a bunch of noise here in Elastic. So obviously we haven't seen some stuff in a little while. Let's go to the last hour. I'll just go to the last 15 days. I just spun up this Elastic instance today, so this should show everything. So you'll see here right off the bat, we've got a TPMS system, Schrader something or other. So these devices, they're sending off multiple signals, each of them with a different data point. And so you'll see those reflected here. A lot of it's just stuff from MQTT. You can see down here, here's the message that was sent. Looks like this had a date on it. Yep, you'll see here. It's part of the time topic. So it's a TPMS device. This is the specific device ID, or the specific device unit manufacturer ID, and I think this is the unique ID of the unit itself, and then this is the message that it sent, and then that is the message value. And it's pretty much just repeating that over and over. You'll see some stuff here, pressure PSI.
Those are all unencrypted?
These are probably not unencrypted. Like I said, like some of these libraries, they do the demodulation. They take that IQ signal, turn it into the packets, and then from there, whether it's insider knowledge or hacking or whatever else, they figure out what each packet means and turn that into meaningful data.
Tags to describe data fields?
Sorry, one more time?
Tags of some kind to describe data fields?
What do you mean by tags?
It looks like they're separating data set separated by slashes there.
Yeah, so the question was, are they using tags to delineate the data? It's really,
Well, I meant to identify the data, is my question.
yeah, so it's really, you have to have inherent knowledge of what the packet structure is, right? So there will typically be what they call a preamble, which will be a series of bytes to basically sync up your tuner to. That's where you know the message starts. And then there will be documentation or reverse engineering on what each packet contains, right? And so from that, typically it'll be a bit or something like that that'll tell you what that message represents and then the data value behind that. And then there's also syncing bits too to make sure that the message is properly understood and it's not
When you talk
jargon.
about scientific data, would that include like sensors they use for agriculture or any farm machine, anything like that? Also, they fit in that category?
Yeah, so the question was, is there use in the agriculture industry? I would say absolutely, yeah. Yep. Yep. And so just going through, there's stuff on like, I'm assuming this is a smoke detector of some kind. So you obviously in industrial buildings in this area, you're going to have some pretty sophisticated fire suppression systems. They're going to be talking to each other. It's not just everything's just wired in. They're going to be, pulsating their statuses back to some sort of centralized system to monitor, make sure systems are all up and good. I don't know if that's from this building or the convention center next door. Curie security, all kinds of stuff. Opened, that could very well be the door system here. Looks like this says door. I'm assuming open means a door or egress method was opened and the message is 1, so true. Yeah, a lot of security stuff, smoke stuff. I'd be interested to see if we open one of these doors, if we would see a message pop through. But that's the kind of stuff I've been working with. And so, like I was saying, there's kind of 2 different bands I'm most interested in. The 4331 is pretty cool. None of the stuff, like meters don't typically operate on those particular bands. That's all in the 900 to 928, I think it is, band. So that's the other one I've been playing with. There's another piece of software called, pretty intuitive, it's called RTL AMR. That one There's another project. It's like a plugin for that will, I forget the database. I think it's Grafana. That's a pretty popular one. Like a lot of folks that are doing this are feeding Grafana. So that project, I think, specifically feeds into Grafana, and I'm working on a contribution to that to also get it into Elastic. So once I get that, I'll be able to start playing around with that a little bit more. But for the most part, it's just been broadcasting consumption values. I'm assuming like my neighbor's gas meter or something like that. I have no idea where it's coming from. That's all I've really been able to find so far. So that's been my journey to date. Obviously, I'm sure we'll be able to share these slides. These are the resources that I have so far, the GitHub repos that I've been using. I included my FCC ID link to the device that I'm looking at if anybody's curious. It's also good because it's kind of hard to find the FCC ID documentation site. There's a lot of like clones out there with some weird links in there. So that's a good way to jump right to the FCC documentation pages. And then, yeah, some links directly to the RTL SDR blog page. They got a lot of content on there. A lot of really cool content. And there's a lot of cool projects, too. I have a sort of an old acquaintance who works in the National Weather Service. So something I wanted to play around with is when they send up weather balloons, those operate within the bands that these can read. And apparently, it's pretty easy to pick up those signals. So you can pick the telemetry up from weather balloons. When they're at their maximum height, which is like 45,000 kilometers, like they broadcast for about like 300-mile radius. And so we have a national weather station that does do deployments down in the Baltimore area. So I figured, with winds kind of prevailing northeast, we might be able to pick up some of that signal action. So I've been doing some research on that, and I might play around with that space. There's a pretty good write-up on it on the blog. And then, yeah, that's just going to be continuing to try to hack my water meter so that my hope is I can freak out that guy, right? So he comes up to my house, he's about to scan, I'm like, hold up, and tell him to the very milliliter how much water I've used, and just scare him into never coming back. Or see if I can get some information about what he's using to scan that, because my assumption is that device is probably very general purpose. So hopefully I'll be able to like figure some stuff out about that too. Yeah, it's true.
Yours is much more benign than I was thinking. I was thinking like try and send an erroneous message, see if you can get obviously the wrong value. Your neighbor used 5 million gallons.
Not a bad idea.
Put a shield up so they can't detect it.
I'll put my own sensor there. It just puts memes on a little scanner. All right, that's it. Goodbye. Go explore your airwaves. Of course, thank you. Thank you. And like I said, there's a giveaway of this device. It's actually a whole little kit. Comes with the actual receiver. It's basically this kit. Has a tripod. Has some bigger antennas that come along with it too. It's just a dipole antenna. So if you want to do stuff like look at NOAA satellites, you're going to have to get into the garage and build your own fancy helical structures. But it's pretty cool for just picking up basic signals, stuff around your neighborhood, and possibly hacking your local infrastructure.
Cool. We'll have a short break for like 5 to 10, so feel free to mingle, grab another beverage. Bathrooms over there if you need that. And we'll get Luke set up for the next talk.
Thank you. I guess I'll keep this up.